Professor Umesh is from Department of Electrical Engineering of IIT Madras. He is an expert in speech processing and machine vision and machine learning. Welcome, Professor.
Let me get started. So thanks, Professor Junjunwana, for inviting me to this talk. So as he said, I mostly work on something called automatic speech recognition. Or the simpler way to say it is speech to text, and we focus mostly on Indian languages. I mean, we have been working for long in Western languages simply because the data was easily available, and most of the work in this area has been in Western languages. Most importantly, I think American English. I think the US supported this effort from the 1990s. So now we want to change the whole picture, and we want to make things available in Indian languages so that the community can grow here, right? And as Professor Ashok mentioned, one of the typical ideas that we have is that there should be no involvement of text, right? You do your everyday life with just speech. And how can you do that? And it makes a lot of sense in India simply because most of us, struggle to read and write, right? A large segment of the population. And I mean, older guys like me, I can't type. I don't know how you guys type WhatsApp like this without looking, right? Most of you are very young. I just can't do that, okay? So I am technologically challenged in that sense. I don't know how to type these things, and I would rather speak to something, right? So the goal here is that, you speak something, right? But 99% of the internet is in English, right? So if I want to make a reservation, railway reservation, so there are now Hindi websites, but that's about two, and I need to know how to read and write Hindi, right? Forget about Assamese or something like Bodo or something. You are not going to have that kind of facilities, right? So how can I get the power of internet, the power of access to information just by talking, right? And that is what he alluded to at the beginning, that we have three broad areas. So one is speech, which is the top layer. That is the only thing you will need to worry about. You know how to speak your language, and you can understand your language. And the idea is that the technology speech layer will convert it to text, right? In the left part of it. And then translation technology is very, very important. Again, that is a language technology, and unless we can do a very good job of that, we cannot, progress further. So once I have the translation layer coming in and converting it to English, then I can query whatever I want, right? And I think there are enough demonstrations from Professor Ashok's group itself to worry about how you can access, and ChatGPT is one primary example, right? You can fetch a lot of important information. It doesn't solve all the problems, but you are progressing, right? But the information mostly is English. I mean, it's very, very hard for even ChatGPT to work in Assamese or Bodo or Punjabi or any of these things, right? Because it's not built for that, right? And they will not address those problems. It is we, right? We have to address those problems. I'm a Punjabi. I want to do something for my community, right? So we need to do that, right? And the reverse process has to take place, right? So once I have the response in English, I need to convert it back to whichever native tongue that I'm speaking. The native text. And Professor Hema's, TTS systems will handle the speech output. Okay. So this is typically how we are visualizing something that will happen in the next 5 years, okay, or 3 years, or if you ask Professor Ashok, he'll say, can you do it tomorrow, right? I mean, we want it as soon as possible, right? And we are there, but not there, okay? So there is, the technology is still not robust, right? So still it will make mistakes, but we are evolving. We are doing, improving it all the time, and we believe this should be a community effort, and that is one of the reasons why we are excited about having such a big set of people who are interested, and Professor Ashok has been one of the people who are pushing and getting these technologies out, right? And then you might ask, we don't want to rediscover or reinvent the wheel. Why do I want to do something which Amazon or Google or Microsoft have already done it, right? Have they not done it for Hindi? That's a question you'll ask. Yes, they have. But then there are some issues with any of these big companies, right? First of all, they're not available in all the 22 languages, okay? And as I will show, we are going to be much better than them in many of the tasks, okay? So what we build in-house is going to be much, much better than whatever they have, simply because they're not focused on those languages, right? Secondly, it's a paid service, right? I mean, you will have this Google Translate and all, but if you want to run a company, if you want to run it as a service, obviously Microsoft or Google is spending a lot of time with their GPU, right? They are not going to spend that amount of resource unless they charge you. And once they start charging you, no company can make profit, right? Because it leads into your profits just to get those services running, right? Third, and the most important is, we are going to make everything open source. We are going to give you everything. We are going to give you the models, we are going to give you the software, the GitHub codes, source codes, you do what you want. We want somewhere somebody to start, right? And as I said, we are at a pretty good threshold. We are better than many of these competitive guys, okay? But they are not going to share, they have to make money. But we are academics, right? And so we believe that the way that the community can grow is I share everything with you and I want you to use that, improve on it and give it back to us. And we are going to put it on some website, you keep contributing to that website, right? Or you build your own website and your own systems and say this is better than us, we are happy, right? So that is the primary goal of this whole effort, okay? And so with these two remarks, I want to go and speak specifically about ASR, which is my field of interest. Basically, all that it does is convert speech to text. Okay, so what does it mean? That it's not going to understand what you said. There's a separate layer that has to interpret what you do, right? Suppose you say, I want to go to the bank. The interpretation is not clear. Do you want to go to the finance bank, I mean, to take cash out, or the river bank, to have a boating ride or something, right? It's not clear, right? So often the context is very, very important for sense to be made, okay? So we are just going to convert it to text, okay? And broadly, there have been two ways that we have been doing, okay? One is what was traditional, at least until about 5-6 years back, which is called the conventional Gaussian mixture model, gated Markov model, the GMM HMM models. They are still very good. I mean, so and then there is the deep learning, artificial intelligence, machine learning, blah blah blah. End-to-end systems. They are very good. Okay, but one has to understand that there is no one-size-fits-all solution. Okay, you cannot throw away the old. The old has a lot of understanding of mathematics. Okay, and for many applications, the older system may work far better than the newer systems, okay? The advantage of the newer system is, if you have a lot of data and you have a lot of compute power, both of which are very, very expensive, and big companies could do that, right? They have enormous GPU power. For example, Google uses 200,000 hours of transcribed data only for American English. Alexa uses 160,000 hours of manually transcribed data for their American English system. What am I going to talk? I'll show you some data. I have 1,000 hours, maybe with great difficulty, 500 hours, 1,000 hours. And so we're competing with so the idea here should be, can we come up with more better methods, innovative methods, so with the limited data to do better, right? That's where the research should be focused on, right? Simply because we can't afford the kind of compute power. So even if the chat GPT is, that's why I think Sam Altman made the statement, India cannot make this. It's just not worth the effort, right? So every question that you're asking, it's guzzling, energy, so much energy. We can't afford that kind of cooling, that kind of cost. If I am going to get 10,000 hits for GPT, it's not going to be sustainable in the long run. They are making it as a show, and then they're going to monetize it, right? At some point, they have to recover the cost. At that time, you're going to be bitten, right? So we have to worry about how intelligently. So there are still challenges in many of these deep learning methods, okay? So I'm telling you all this because people may not mention about this. You're building a system that's going to consume so much energy, you're going to actually, it's a pollution of the environment that you're not even talking about, right? So that's the basic idea, but we are going to do end-to-end systems, but I think we should do it more smartly, and I'll talk about some of the efforts that we are doing, right? So there are two broad ways that you can do any deep learning, any learning algorithms, right? It's similar to what we do. One is, we are taught, we mimic something, right? When you're young, you're say, amma, appa, you keep repeating it, right? So you are trained, right? So there's a supervision that happens. So in a supervised framework, in today's deep learning methods, we use basically something called transformers, okay? And so the input of the transformer will be a waveform, and from that we'll extract something called feature spectrogram, and the output will be a sequence of letters or sequence of the characters that make up the language, right? So if it's English, it'll be a sequence of English characters. If it is Hindi, it'll be the Devanagari script coming, okay? And we have some in-between representation. We don't usually go to the word level. We do some sub-word kind of representations. Something called byte pair encodings will come. So this is going to be a black box as far as you're concerned. You'll give an input, you'll get a sequence of words. And we are going to train this. So to train this means I have to give it a lot of data where I give the input audio and give the what should be the correct text that should come out, right? So that is called the transcribed data. Manually people prepare this data. As I said, Google has 200,000 hours only for English. I think they have already hit 30,000 for Hindi, okay? So we are, but not for many of the other languages, right? So we have to have that parallel data, audio and the manually transcribed data. We are working to build a small corpus. We will be releasing it shortly. But with this method works very well. This is supervised learning. Some of you might have heard of OpenAI's, not the ChatGPT or the GPT. They also have a speech recognition module called Whisper, okay, which is very good in English. Okay, Whisper is basically a transformer model. It's exactly the same architecture, but they have built it on 680,000 hours of data. Okay, manually transcribed. I mean, not manually. It's weekly supervised, but it is transcribed data. Okay, so. There's an alternate approach. What if I don't have a lot of data, right? So then comes what's called the self-supervised learning framework. So I'm talking about two frameworks. One where I have supervised data, where I am given audio, I am given the correct transcription, correct orthographic transcription, correct text, and the machine learns. And then when I give a new audio, it will try to produce a new text output, okay? Here, I don't give it any text, I'm just going to take a lot of audio, and from that audio itself, I'm going to set some kind of a task for it to learn, okay? That is why it's called self-supervised. It is learning from its own data, from the data that I give, from the data itself, you set an objective function, and it learns, okay? And why is this good? So suppose I go to China, right? I don't know Chinese at all, right? I can't understand what it is doing. But when I keep listening to Chinese for a long period of time, from whatever my previous understanding, I can pretty much understand what is happening. Nobody is going to say, he says something in Chinese, this is the correct thing in Hindi, and that's one way of learning, right? So you go to a Chinese school or you go to a Spanish school, they'll say, this is said in Spanish, es un libro or something, and this is a book. Nobody teaches you like that. That is one way of learning. But sometimes you automatically learn, right? Because as humans, you internalize, okay, there is a horn there, that is not speech. If I do something like this, the machine thinks, is that a word I should interpret? But after a certain point, it realizes this is not important for my analysis. This is some noise, right? So this is called self-supervised learning. And if you can, if you have seen GPT and Word, which are two things you would have heard from text processing, right? Both are very, very popular, or Llama, or any of these things, Llama, Lambda, whatever you want, right? All of these are self-supervised text learning processes, okay? But for speech, where there are other kinds of models, which are called WaveLM, Hubert, and Wave2Vec. As you can guess, all three have come from which one? The big companies, because you need enormous computing power, right? So WaveLM is from Microsoft, Hubert and Wave2Vec is from Meta, Facebook, basically, okay? So, what have we done? So, for the same benchmarks, right? So, this is an English task, right? And for example, WaveLM is done on 96,000 hours of data, okay? And Hubert is built on, again, 60,000 hours, and Wave2Vec 2.0 on 60,000 hours. So, we said, let us come up with a better method which will use lesser data, okay? And there is a challenge. So this is again on the Western languages, on English. If they claim they are so good, can we Indians compete with these guys, right? So that's the whole idea of this. And you can see WaveLM is right on top, right? This is a benchmark which rates which are the top 5, top 10 models in the world for this particular task, okay? So if you look at WaveLM, obviously it's got 96,000 hours, so it's going to be a really good system. And then there is also the WaveLM base, which is built on 60,000 hours, I think, right? But both our models, which are in green, which is called Data2Vec AQC and CCC Wave2Vec, are both built only with 960 hours, less than 1,000 hours of data, right? But we have done some, intelligent ways to reduce the data and still get performance that's competitive to 96,000 or 60,000 hours. And you can see we are, I don't know, 1, 2, 3, fifth and sixth, right, in the challenge. This is a global challenge, okay? Nothing that, we give the public, it's a public challenge, so anybody can participate. And the base model for that, the ideas are improvements of wave to wake and data to wake. Those are the red ones, so they are much below. So, and they use, a lot of these guys use quite a bit of data also, okay? In spite of that, we are much ahead. So the idea is that with good research, you can compete with the rest of the world. I mean, okay, so that is the point. I mean, we are capable of competing with the rest of the world, okay? And these are old results, about 5 months old. We are releasing in a couple of weeks new models, new data, new challenge. I mean, new numbers. But you can see in many of these things we are comparing ourselves with the Microsoft, the Google, and there are a lot of other people also working in India itself in trying to get these models out into the open world. And you can see ours is the golden yellow kind of a thing. It is there. It is competing with and the first two are the Googles and the Microsofts. Okay, so we are pretty competitive to. This is again a standard test set created in a consortium of Meta, Google, and CMU, right? And then there's the other one also, which is the OpenSLR, which is again by Johns Hopkins. Again, the golden yellow. You can see that we're still. I mean, our present numbers are better than that. But for many of the languages, we are still better than the Googles and the Amazons, Googles and the Microsoft, right? So this is the basic idea that I have. I mean, I want to give you the big picture. We do have demos, but I'm not sure if I can play those demos. I would like to show at least ASR. Let me see if I can do it. But one thing before I wind up, I wanted to say that we are collecting speech data. Like as I said, if you go into the outside world, we have no data. We have no models in Indic languages, right? Nothing for, no codes for you to start with, right? On the other hand, in Western languages, there is some amount of public data available. American English, you will find quite a bit of data. So unless you have data, models, codes, it's difficult for you to start, right? And we also have for all of these APIs. So if you are starting a company, we are happy. You take our APIs, make money out of it. But if you build something useful for the society, we are very, very happy, okay? So we are releasing data, we are releasing models, we are releasing all the GitHub codes, recipes, and so on. And the idea is to build a community, okay? Can I just give a demonstration? Sir. Okay, so let me see if I'm very happy to meet all of you, and I hope I have inspired you guys to take up this effort and build a speech community and get this going. We have also something called streaming model, but this is. But I'm very happy to meet all of you. Or I can even play the audio. You can see it. Okay. I'm very happy. The speech community and get this going. So and things like this, we typically don't speak. We do speak code switch. This is something we are excited. We have been trying to work on this. We don't have data which is code mixed, but a lot of the urban population do speak. So we took it as a challenge where we had only English data and only Hindi data, and we tried to build something that works for both languages. My Hindi is not good, but I'll try. Okay, so I'm very happy to meet all of you. मुझे बेहद खुशी हुआ कि आप सब यहाँ आके मेरी लेक्चर को सुने और मुझे आशा है कि आप you will help me build a community for this effort. I don't know. That ours we will post process, that is by hesitation. So normally in speech we don't speak fluently. Okay, so that's called cognitive load. I'm thinking and therefore I'm saying for my brain to process what next I should say. That's called disfluencies. Okay, so I don't know if it came correctly. I'm very happy to meet all of you. मुझे बेहद खुशी हुआ कि आप सब यहाँ आके मेरी लेक्चर को सुने और मुझे आशा है कि आप you will help me build a community. So these kind of things are very, very difficult. Okay, it looks trivial for you, but it's difficult. Okay, and I don't know much of other languages. My Tamil is extremely bad, but I'll speak. Okay. வணக்கம் உங்கள் எல்லோருக்கும் என்னோட நன்றிகள் இங்க வந்ததுக்கு ரொம்ப சந்தோஷம். Okay, I'm not very good, but I can't read Tamil also, so you will tell me it's did it come correctly?
Yes.
வணக்கம் உங்கள் எல்லோருக்கும் என்னோட நன்றிகள் இங்க வந்ததுக்கு ரொம்ப சந்தோஷம்.
Converted exactly.
Or I know a little bit of something else Kannada here.
Last word.
ನಮಸ್ಕಾರ, ನೀವೆಲ್ಲರೂ ಇಲ್ಲಿ ಬಂದದ್ಗೆ ತುಂಬಾ ಸಂತೋಷ. ನೀವು ಇಲ್ಲಿ ಬಂದು ಕೆಲಸ ಮಾಡಬೇಕು ಅಂತ ನಮ್ಮ ಕೋಡಿಕೆ or whatever. Okay, so I'm sorry. So you get something wrong at the end, but that is pretty much what should be. Anyone knows Kannada here? Okay, so I don't know if it came correctly.
Please confirm.
ನಮಸ್ಕಾರ, ನೀವೆಲ್ಲರೂ ಇಲ್ಲಿ ಬಂದದ್ಗೆ ತುಂಬಾ ಸಂತೋಷ. ನೀವು ಇಲ್ಲಿ ಬಂದು ಕೆಲಸ ಮಾಡಬೇಕು ಅಂತ ಕೋಡಿಕೆ. Okay, so I hope you all understand what I want, but the effort is that we want you to build a community for us.
Thank you very much for briefly covering all the various different models in automatic speech recognition and also given a wonderful demo. And any questions?
Yeah, please. Yeah.
Just one or two questions? Yes, there is one question.
Possible to do pattern. And I would like to know, is this a software, ASP?
Pardon?
See, whatever you have recorded, you have spoken, that was reflected as a speech. So is it a software or tool?
Yes.
I was not able to visualize what comes on the screen.
Okay.
Also the visual pattern.
Okay, so basically it is a big software which we have written, right? But I mean, it's basically a model, so it is some kind of a statistical model sitting at the back. What I showed you is a web interface, okay, which we have, where you click and you speak and the text comes out, okay? So that is what I've shown on the slide, on the demonstration.
That would be converted as a text.
Correct.
So it's like Google Docs, we use voice assistant.
Correct.
So whatever we dictate, that would be typed in a text.
Correct.
Am I right?
Correct. So this is the first step. Obviously with this you can do a lot of wonderful things. Like as I said, with TTS and you have a query, then you don't even have to worry about text itself. You query, this will get converted to text, it goes, it picks up anything from the web, and then that gets converted back to speech. So it's a pipeline that you have to worry about. This is only the first step in the pipeline.
Okay, thank you.
Thank you very much.
Hello. Yeah, Professor Umesh, I have a query like how good it is in detecting automatically which language I am speaking.
So I chose the language here, if you see, but the idea is that you can build a small segment in the beginning, which will be what's called language ID, and then it'll just pick up which language you're speaking and then start converting to text.
Actually, there's a team in IIT Madras which is built actually for 8 Indian languages. It will automatically recognize the language. Okay.
By the way, like Professor Emma said, I work in ASR, she works in TTS, but we have a consortium of 23 institutes which work on different aspects. Some people work on pathological speech, for example, right? Impaired speech. Some people work on language ID that you're talking about. Some people work on speaker. You want to use voice as a biometric, right? So there are teams that work on biometrics, voice as biometrics. So there's a huge effort going on in India in speech technology. Okay. So she is the coordinator. Okay, so yeah.
What is the technology you used behind this? Is it Python or what is the core technology there?
So it is all based on PyTorch, basically. So the backend is all PyTorch. It's all open source. So we build on that. Yeah.
More questions are here. For example, you mentioned a very small data set as a source for training your.
Correct.
For example, you have 5 or 6 languages here.
Correct.
Considering all the other languages to be onboarded, what is the method or procedure which is in place to, for example, I may be thinking about crowdsourcing sample data. In that case, what is behind? How you collect this data? Is it simple, complex?
It's actually a complex task. From our experience, I mean, our students are now gone to Google's and Microsoft's and Amazon's, right? So from what we understand, crowdsourcing looks like a good option, but actually it's not a good option because people are not very, very diligent. They're not sincere when they do that, and there's no way to check the quality. So crowdsourcing in the end comes out to be as expensive as asking, we hire vendors who will go to the field and pay people money and ask them to have mock conversations, and then we carefully transcribe that. That is, even though the quality of data, even the quantity is less, the quality is so good that we often get much better improvements compared to large crowdsourced data. So that is our experience.
Thank you, sir. For example, now, even you can get ordered your own avatar in AI, right? So that's going to give a set of words. You can speak in your own words, and then it creates a model with your own pitch and tonality and things like that. So my question is, do we have any templatized text so that all the, I would say, sounds are captured or something like that?
Yeah, so there are two different problems you're talking about. One is what we call as prompted TTS that she'll talk about. And there are legal issues and there are ethical issues. So and today's technology we can do, but it's not widely available simply because of the legal implications. I can take about 15 seconds of your speech and probably get exactly whatever text I tell will sound exactly like what you say. But then that becomes deep fake, right? So tomorrow I get a phone call from my wife saying, hey, send me $1,000. I am going to trust that, right? Because it's exactly like my wife's voice and she's sounding very, flustered, and I'm going to send somebody that money. So there is this ethical and legal issues, so that is why that is being downplayed currently, okay? So there are issues there everywhere, okay, so yeah.